Tonight, we're going to follow the loneliest journey in human history. There is a profound paradox at the heart of this voyage, where a computer built in 1977, possessing less processing power than a modern car key, is currently the only human object defining the absolute edge of our solar system. It is a fragile collection of circuits and gold-plated aluminum, drifting through a void so vast that the distance to its home is no longer measured in miles, but in hours of light. Expectation, a 4-year mission to scan nearby planets and return data to a waiting world. Reality, a machine that has outlived its purpose to become a permanent ghost in the interstellar void. When the Voyager probes first left the atmosphere, they were intended as scouts. They were designed to capture the first high-resolution images of the gas giants and then fade into the background of space. No one expected them to become the vanguard of our species, venturing into regions where the sun is no longer a warm presence, but merely the brightest star in a cold, black sky. To think of this machine is to think of a relic. It carries a level of computing power that would be laughed at by any modern engineer, yet it continues to calculate its trajectory and pulse its remaining energy across billions of kilometers of vacuum. Picture the probe now suspended in a silence that is absolute. There is no wind, no sound, no atmosphere to carry a vibration, only the rhythmic, lonely hum of its radioisotope thermoelectric generators, slowly decaying, providing just enough warmth to keep the electronics from freezing into a permanent sleep. The gold foil wrapped around its body, meant to protect it from the radiation of Jupiter, is now pitted and scarred by microscopic dust, each impact a tiny scar from a journey that has lasted nearly half a century. We often think of the edge of the solar system as a wall or a clear border, but for Voyager, it was a slow fade. It is a transition from the familiar breath of the sun to the crushing indifference of the galaxy. The probe does not know it has left home. It only knows the data it collects, the plasma densities it measures, and the slow, steady drop in temperature. It is a messenger with no one left to talk to, carrying a golden record of our music and our laughter into a place where those things have no meaning. This is the essence of the Voyager mission. It is the act of throwing a bottle into a cosmic ocean, knowing that the shore it reaches may not exist for millions of years, or that the hands that find it may not be human. The machine is an extension of our own curiosity, a physical manifestation of the desire to know what lies beyond the horizon. But as it drifts further, it ceases to be a tool of science and becomes a monument to our existence. It is a speck of dust in a continent of emptiness, traveling at speeds that would cross the United States in seconds, yet moving so slowly relative to the scale of the Milky Way that it is practically standing still. The isolation is not just physical, it is temporal. The signals it sends back to Earth take hours to arrive, traveling at the speed of light, only to be caught by massive dishes in the desert. By the time we hear the probe's voice, it is already speaking from a place it left hours ago. We are listening to a ghost, a transmission from a version of our solar system that no longer exists in the same configuration. This journey was not an accident of trajectory, but a calculated gamble. The engineers at NASA JPL did not simply launch a rocket, they timed a dance. They looked at the clock of the heavens and saw a window of opportunity that occurs only once every 176 years, a rare alignment that allowed a single craft to slingshot from one giant world to the next. But before it became a ghost, it had to navigate a precise celestial clock. To understand the launch of the Voyager probes, one must first understand the patience of the solar system. In the mid-70s, the engineers at NASA's Jet Propulsion Laboratory were not looking at a calendar of months or years, but at a clock that ticks once every century and a half. They discovered a rare planetary alignment, a celestial window that opens only once every 176 years, where the outer giants, Jupiter, Saturn, Uranus, and Neptune, drifted into a specific geometric relationship. This was the foundation of the Grand Tour trajectory. The plan was not to fight the immense gravity of these worlds, but to embrace it. By timing the launch to this alignment, NASA could use the gravity of one planet to slingshot the spacecraft toward the next, stealing orbital momentum to accelerate the craft without needing impossible amounts of fuel. Expectation, a predictable path through the outer planets, a series of clean arcs from one sphere to another. Reality, a high-stakes game of cosmic billiards, where a deviation of a single degree at the start would mean missing a target millions of kilometers wide by the time the probe reached the edge of the system. The Grand Tour was a masterpiece of orbital mechanics, a sequence of gravitational assists that allowed Voyager 2 to perform a feat no other human object has ever repeated, visiting all four gas and ice giants in a single, continuous journey. Consider the sheer precision required for such a voyage. The probes were launched in 1977, not as independent explorers, but as twin sentinels riding a wave of gravity. The trajectory was calculated to ensure that as Voyager swept past Jupiter, the planet's massive pull would bend the probe's path and fling it outward toward Saturn. Then Saturn would do the same, pushing the craft further into the dark toward the tilting axis of Uranus and the frozen winds of Neptune. It was a chain reaction of momentum. Each encounter was a gamble with physics, a moment where the machine had to fly through a precise corridor of space, close enough to be captured by the planet's gravity, but far enough to avoid being pulled into a crushing descent. The Grand Tour trajectory turned the solar system into a series of stepping stones. Without this 176-year alignment, reaching Neptune would have required decades more of travel or a rocket the size of a city. Instead, the engineers used the architecture of the heavens to shorten the distance. They turned the very things that usually block our path, the immense gravity wells of giant planets, into the engines that drove the Voyagers away from home. As the probes accelerated, the distance between Earth and the machines grew into a chasm that defies human intuition. The Grand Tour was not just a map of destinations, but a lesson in the terrifying scale of the void. For every hour spent observing a planet, there were months of drifting through a darkness so absolute that the sun began to shrink from a warm disk into a distant piercing needle of light. The probes moved through the vacuum, their gold-plated electronics humming in a temperature that hovered just above absolute zero, relying on the precise calculations made by humans in a room in Pasadena years before they ever left the atmosphere. The trajectory was a promise made to the future, a path carved out of the math of the 70s that would eventually lead the probes beyond the reach of the sun's breath. Every slingshot, every gravity assist, and every course correction was a step away from the familiar. The Grand Tour was the only way to reach the outer rim, a one-way ticket that traded the possibility of return for the chance to see the unseen. The machines were no longer just instruments of NASA. They were passengers on a cosmic current flowing outward toward the interstellar medium. The engineers had mapped the points of contact, the dates of the closest approach, and the expected data returns. They had a vision of a solar system that functioned like a clock, where the planets moved in predictable, elegant orbits. They believed the path was clear, a vacant highway of vacuum waiting to be traversed. However, the space between these giants was not the empty vacuum we imagined. As the probes continued their outward drift, they approached a boundary that had existed since the birth of our star, a place where the influence of the sun finally gives way to the cold pressure of the galaxy. For decades, the scientific community operated under a specific assumption about this border. We expected a clean and smooth exit, a cinematic line in the sand where the solar wind simply stopped and the interstellar medium began. The reality was far more chaotic. The transition, known as the heliopause, is not a wall but a turbulent, shifting zone of compressed plasma. As Voyager 1 pushed through this region, the data flowing back to Earth showed a world of violent fluctuations. The solar wind, which carries the sun's magnetic field and charged particles, does not simply vanish. Instead, it crashes into the interstellar wind, creating a crushing, shimmering interface where the density of plasma spikes and dips in unpredictable waves. It is a cosmic shoreline where the tide of our home star meets the deep, dark ocean of the Milky Way. But the most profound revelation came from the way this boundary was shaped. We had long imagined the heliosphere, the bubble of solar protection we live within, as a neat, expanding sphere, a perfect globe of light pushing back the void in every direction. The measurements from the Voyager probes shattered this symmetry. The reality is that our solar bubble is asymmetric, stretched and distorted by the movement of the sun through the local interstellar cloud. It is shaped less like a ball and more like a comet, with a blunt, compressed nose facing the direction of our travel, and a long, trailing wake stretching out behind us. This discovery changed our entire understanding of our place in the neighborhood. We are not sitting in a static bubble, but are instead passengers on a galactic ship, carving a path through a medium of gas and dust that we are only now beginning to map. The heliosphere is our only shield, a magnetic cocoon that filters out the majority of the lethal cosmic rays from distant supernovae. To cross the heliopause is to step out from under the umbrella. It is to enter a region where the rules of the solar system no longer apply and where the probe is exposed to the raw, unfiltered radiation of the deep cosmos. The transition was not a single moment of crossing, but a prolonged struggle against the pressure of the interstellar medium. Voyager 1 felt the solar wind slow down, then stutter, then finally vanish, replaced by a sudden surge in the density of galactic plasma. It was a whisper that shook an entire field of astrophysics, confirming that the machine had finally escaped the cradle. The probe was no longer feeling the breath of the sun. It was now swimming in the currents of a galaxy that had existed for billions of years before our star was even born. This boundary represents the furthest edge of human influence. Every piece of matter in the universe is connected by gravity, but the heliopause is the limit of the sun's active reach. Beyond this point, the probe is a stranger in a strange land, a tiny fragment of aluminum and gold drifting through a continent of emptiness. The measurements captured by the instruments during this crossing were not just data points, they were the first physical sensations of the interstellar void ever recorded by a human creation. The silence that followed the crossing was heavy. The plasma waves became the only heartbeat the probe could detect, a low-frequency hum of the galaxy itself. There is a profound stillness at the edge of the heliopause, a place where the warmth of the inner solar system is a distant memory, and the only light comes from the cold, uncaring stars. The asymmetric tail of the heliosphere stretches out behind the probe like a ghost, a fading reminder of the home it left behind. As the Voyager 1 continued its glide into the interstellar medium, the distance between the machine and the sun became so vast that the very concept of a solar system began to dissolve. The probe was no longer a part of the clockwork mechanism of the planets. It had entered the great open. It was now a lonely sentinel, recording the temperature and the magnetism of a space that is fundamentally different from anything we have ever experienced. The transition revealed that the void is not empty, but filled with the debris of dead stars and the remnants of ancient explosions. The plasma the probe encountered is the breath of the galaxy, thin ionized gas that permeates the space between the stars. By measuring this gas, Voyager provided the first direct evidence of the environment we are drifting through. We learned that we are moving through a region of space that is denser than some parts of the galactic void, a local cloud that shapes the very boundary the probe just crossed. The asymmetry of the heliosphere means that Voyager 1 and Voyager 2 experienced different paths to the outside. One pushed through the nose of the comet, the other drifted through the flank. Each provided a different piece of the puzzle, revealing that our solar system is not a lonely island, but a vessel cutting through a sea of interstellar matter. The turbulence encountered at the edge was a reminder that the universe does not provide clean lines or easy exits. The transition is messy, chaotic, and violent, a reflection of the immense forces at play when a star fights for its space against the crushing weight of the galaxy. Now, as the probe settles into the steady state of interstellar space, the data has become a slow, rhythmic pulse. The machine is no longer fighting the solar wind. It is drifting with the galactic current. It has become a permanent resident of the dark, a tiny humming piece of Earth that will continue to travel long after the people who built it are gone. It is the first object of our making to truly leave the nest, to step beyond the protective shield of our star and face the infinite. But to truly grasp the magnitude of this boundary, we cannot look at the plasma or the magnetism alone. We must look at the physical reality of the object that is witnessing it all. We must consider the fragility of the machine that has survived for nearly half a century in the most hostile environment imaginable. To understand this boundary, we must first look at the machine drifting through it. Picture the probe as it is now, a solitary white-high gain antenna, once the pride of 1,000 engineers, now reflecting a sun that has shrunk to nothing more than a particularly bright star in a sea of darkness. Its gold-foiled body, designed to shield delicate electronics from the freezing void, is no longer pristine. It is pitted and scarred by the impact of microscopic dust grains, traveling at speeds that turn a speck of silica into a kinetic bullet. It drifts in a silence so absolute that it feels heavy, a physical weight pressing against the chassis of a machine that has forgotten the sound of wind, the pull of a tide, or the warmth of a summer afternoon. This silence was not always so heavy. Before it reached the interstellar void, Voyager 2 bore witness to the most alien corners of our own neighborhood. It drifted past Uranus, a world that defies the logic of the solar system. While every other planet spins like a top, Uranus tilts on its side, rotating nearly 90 degrees off its axis. To the probe, it appeared as a pale sign sphere rolling through the dark, its poles facing the sun in a surreal sideways orientation. There was no roar here, only the ghostly hum of a frozen atmosphere and the thin vertical rings that sliced through the dim light. And then there was the blue silence of Neptune. As Voyager 2 approached in 1989, the planet emerged not as a solid mass, but as a deep sapphire haze. The images captured by the probe showed a world of violent supersonic winds and a darkness so profound that the blue hue seemed to glow from within. It was the furthest reach of the Grand Tour, a final checkpoint before the long exit. The probe recorded the screams of methane storms and the lonely orbit of Triton. But as it turned its back on the blue giant, the noise of the planets finally faded. Now the environment has changed. The probe is no longer navigating the gravity wells of giants. It is moving through the interstellar medium where the density of matter drops to a few atoms per cubic centimeter. The radiation that once felt like a storm is now a steady cold rain of galactic cosmic rays. The thermal generators, the RTGs that provide its heartbeat, are cooling, losing a few watts of power every year. The machine is becoming a ghost, a fragment of 20th century ambition, floating in a region where time seems to stretch and flatten. The telemetry it sends back is a whisper, traveling for nearly 23 hours at the speed of light just to reach a receiver on Earth. By the time we hear the data, the probe has already moved thousands of kilometers further into the dark. It is a conversation across an impossible distance, a dialogue between a dying machine and a civilization that has evolved entirely since the probe was launched. There is a profound stillness to its current state. It does not accelerate or decelerate in any way that a human could feel. It simply persists. It is a needle of aluminum and gold threading through a continent of emptiness, carrying the echoes of a world it can no longer see. The high-gain antenna remains locked on Earth, a blind eye searching for a signal from a home that is now a distant memory of light. This small object is now a speck against a scale that defies human comprehension. To grasp the true scale of this isolation, we must leave behind our human maps and translate the distance into something we can feel. Voyager 1 is now more than 23 billion kilometers away from the center of our solar system. To the mind, this number is an abstraction, a string of zeros that means nothing. But let us shift the perspective. If the sun were a single grain of sand resting on a sidewalk, the Earth would be a microscopic speck of dust just a few inches away. In this scale, the edge of the heliopause, the boundary where the sun's breath finally fails, would be a distance of a few kilometers, and Voyager 1 would be a particle of dust traveling far beyond the nearest city, drifting into a wilderness where no other human object has ever ventured. It has passed the point where the sun is no longer a warm presence, but a distant, piercing point of light, no different from the billions of other stars in the velvet black. Even at this staggering distance, the probe is still a prisoner of the void. We often think of interstellar space as a neighborhood of stars, but the reality is a continent of emptiness. The nearest star system, Proxima Centauri, is roughly 4.2 light-years away. At its current speed of 17 kilometers per second, Voyager 1 is moving fast by any human standard, yet it is barely crawling across the cosmic floor. It will take tens of thousands of years before it even approaches another star. For now, it exists in the great in-between. It is in the gap where the influence of our home ends and the influence of the rest of the galaxy has not yet begun. Think of the silence that surrounds it. There is no wind here, no atmosphere to carry a sound, no planetary magnetic field to create a shimmer in the dark. There's only the steady rhythmic pulse of the galactic cosmic rays and the cold, unchanging vacuum. If you were to stand beside the probe, you would feel a solitude that is not merely physical, but existential. You would be separated from every other living soul by a gulf of space so wide that the light from Earth, carrying the images of our cities and our forests, takes nearly a full day just to reach you. By the time that light arrives, the world it depicts has already changed. The people who sent the probe are older or gone. The cities have shifted. The probe is not just traveling through space, it is traveling away from time itself. This is the translation of 23 billion kilometers. It is not a measurement of length, but a measurement of abandonment. The probe is a tiny gold-plated seed cast into a field of infinite black, moving with a singular, unwavering purpose. It is the first time a piece of our world has truly broken the tether of the sun. It is no longer a satellite of Earth, nor a visitor to the planets. It is a citizen of the interstellar medium, a lonely emissary drifting through a region where the density of matter is so low that it could travel for 1,000 years without hitting a single grain of dust. The probe carries with it the weight of our entire species, yet it is smaller than a room. Its antenna, a white dish of precision engineering, continues to point back toward a pale blue dot that it can no longer see. It is a blind eye searching for a signal from a home that is now a ghost of light. This distance creates a strange, haunting symmetry. We on Earth look at the telemetry and see a machine we created, but the machine, in its cold, metallic logic, is experiencing the reality of the universe as it truly is, mostly empty, mostly silent, and impossibly vast. Every kilometer it gains is a victory of physics, but also a surrender to the void. The further it goes, the more the probe ceases to be a tool of science and begins to be a monument. It is a marker of the furthest point a human thought has ever traveled. It is a physical manifestation of our curiosity, pushed to the absolute limit of the reachable. Yet, as it drifts further into the dark, the distance begins to feel intentional. The void does not feel like a barrier to be overcome, but a destination in its own right. The emptiness is the point. The isolation is the message. We see the probe as a lonely object, but in the eyes of the cosmos, it is a flicker of consciousness in a sea of unconscious matter. It is a tiny spark of electricity and gold foil holding onto its warmth for as long as the plutonium in its heart allows. It is a fragile bridge between the biological world of Earth and the cold, inorganic reality of the galaxy. As it moves, it leaves behind a trail of silence, a wake of emptiness that marks the exit of humanity from its cradle. This journey was never meant to be a round trip. There is no fuel for a return, no mechanism to turn back. It was launched with the knowledge that it would one day lose contact, that its batteries would fade, and that it would eventually become a silent piece of space debris. But even in that failure, there is a profound intention. The probe was not just sent to collect data on Jupiter or Saturn. It was sent to witness the edge. It was sent to be the first of us to truly leave. The scale of its journey transforms our understanding of what it means to be alone. We feel loneliness when we are separated from people by miles or years. Voyager 1 is separated from us by a distance that requires a new vocabulary to describe. It is a loneliness that is cosmic in scale, separation so complete that it transcends the very concept of distance. It is no longer away from us. It is in another realm entirely, a place where the rules of our solar system no longer apply, and where the stars are the only landmarks. As the probe drifts, it carries the memory of the world that built it. It carries the sounds of our laughter, the music of our orchestras, and the whispers of our languages. But it carries them into a place where no one is listening. The irony of its mission is that the more successful it is, the more isolated it becomes. Its achievement is its exile. The further it pushes into the interstellar medium, the more it embodies the true nature of our existence in the universe, a small, bright spark of life drifting through an incomprehensible darkness. This movement through the void is not a chaotic tumble. It is a precise, calculated glide. The trajectory was mapped decades ago, a line drawn in the stars that the probe is now following with mechanical devotion. It does not know it is lonely. It does not know it is the first. It simply executes the commands etched into its memory, sending back a few bits of data every few hours, telling us that it is still there, still moving, still cold. The distance of 23 billion kilometers is a mirror. When we look at the Voyager, we are not just looking at a machine. We are looking at the limit of our own reach. We are seeing the boundary between the known and the unknown, between the home we have spent millennia building and the wild, indifferent space that surrounds us. The probe is our furthest finger, touching the skin of the interstellar void, feeling the coldness of the galaxy for the first time. And yet, this solitude was not an accident of the mission. It was not a byproduct of the trajectory or a consequence of the distance. The profound isolation of the Voyager probes was a calculated part of the design. They were built to be the ultimate outliers, to go where nothing else could, and to stay there long after the signal stopped. This loneliness was designed into the mission from the very first sketches. In 1977, the mission was not merely a series of flybys for the NASA Jet Propulsion Laboratory. It was an exercise in cosmic legacy. The team, guided by the vision of Carl Sagan, understood a truth that few other engineers had considered. They realized that the Voyager probes were the first artifacts in human history that would likely outlast the very civilization that built them. While the cameras and magnetometers were designed to gather data for our scientists, there was a parallel objective. They wanted to send a message into the deep time of the universe, a bottle cast into a galactic ocean, containing a definitive record of who we were at a single fleeting moment in our evolution. The result of this vision was the Golden Record. It is a 12-inch gold-plated copper disc etched with the sonic identity of a world that the probe has long since left behind. This record does not contain a manual or a political manifesto. Instead, it holds 90 minutes of the most fundamental expressions of the human experience. It carries the sounds of wind, thunder, and the rhythmic pulse of a human heartbeat. It holds the laughter of children and the first cries of newborns. It contains music that spans the breadth of our culture, from the complex compositions of Bach and Beethoven to the traditional songs of people from every inhabited continent on Earth. The team spent months curating these sounds, attempting to distill the essence of a planet into a few grooves of metal. They included greetings in 55 different languages, starting with ancient Sumerian and moving through the modern tongues of the world, each voice a fragile thread connecting the speaker to an unknown listener millions of years in the future. There are sounds of rain, the noise of a bustling city, and the quiet hum of a forest. It is a sensory portrait of a living world compressed into a physical object that can survive the vacuum of space for billions of years. The Golden Record is not just a library, it is a gesture of hope. It was created with the knowledge that the odds of it ever being found are astronomically low. The vastness of the interstellar void is so immense that the probe is essentially a needle in a galactic haystack. Yet the act of creating it was an admission of our own fragility. By placing our music and our languages on a gold-plated disc, the JPL team and Carl Sagan were acknowledging that the Earth is a temporary home. They were building an archive for a future where we might no longer exist, ensuring that even if the biological record of humanity is erased, the sonic record remains. The record is accompanied by a set of instructions etched in analog symbols on the cover. These instructions explain how to play the disc and where the probe originated. It is a map of our solar system, using the positions of 14 pulsars as landmarks. It tells the finder that we lived here on a small blue planet orbiting a common yellow star, and that we were curious enough to reach out. It is the most honest introduction we have ever written. It does not claim dominion over the stars. It simply says, here we are. As the Voyager drifts further from the sun, the Golden Record becomes the probe's only true purpose. The scientific instruments will eventually fail, the power sources will dim, and the computers will stop thinking. But the record will not decay. The gold plating protects the copper from the slow erosion of interstellar dust. Long after the signals from Earth have ceased to reach the probe, the record will continue to travel. It is a dormant piece of memory, waiting for a chance encounter in the dark. The record transforms the Voyager from a tool of exploration into a ghost ship of human culture. It carries the whispers of a billion lives frozen in time. It is a snapshot of 1977, a moment when we believed we could bridge the gap between the stars with a simple piece of music and a few spoken words. Every greeting, every song, and every heartbeat on that disc is now a permanent part of the interstellar medium. We have exported our existence into the void, creating a legacy that is independent of our survival as a species. The scale of this ambition is staggering. While the probe travels at 17 kilometers per second, the information it carries moves at the speed of light, but the record itself moves with the slow, patient crawl of a machine. It is a bridge across time. The people who spoke the languages on the disc are aging or gone. The cities whose sounds were recorded have changed or fallen, but the record remains unchanged. It is the only part of us that is truly immortal, drifting through a silence that has existed since the birth of the galaxy. The irony is that the record is a message to an audience that may never exist. It is a conversation with a void that does not answer. Yet the value of the Golden Record was never about the destination. It was about the act of sending. It was about the realization that we are a small, conscious part of a vast, indifferent universe, and that our only defense against that indifference is the courage to be remembered. The record is a mirror of our own longing. It reflects the human desire to be known, to be seen, and to leave a mark on a canvas that is infinitely larger than ourselves. It is a fragile, golden heartbeat pulsing in the cold. As the Voyager pushes deeper into the darkness, it carries the sum of our beauty and our noise, moving away from the only home we have ever known. But the record is not the only thing Voyager carries into the dark, and yet the crossing into the void was not a single moment of clarity, but a slow, agonizing realization, written in the data of a dying machine. For years, the mission team at NASA waited for a definitive sign that the probe had finally escaped the sun's protective bubble. They were looking for a specific shift in the environment, a change in the very fabric of the space surrounding the craft. Then, the evidence the world had been waiting for finally arrived. The plasma wave data revealed a sudden sharp increase in galactic cosmic rays. These are high-energy particles born from the death of distant stars, traveling across the galaxy at nearly the speed of light. Inside the heliosphere, the solar wind acts as a shield, deflecting these intruders. But as Voyager 1 moved further out, the shield thinned. The rays began to flood in, signaling that the probe was no longer under the dominion of the sun. This was the smoking gun. The definitive proof lay in the measurement of plasma density. As Voyager 1 approached the boundary, the density of the solar plasma, the hot charged gas streaming from the sun, began to drop precipitously. At the same time, the density of the interstellar plasma, the cold gas that fills the space between stars, began to rise. When the plasma density reached a specific critical threshold, it became clear that the probe had stepped over the edge. It was no longer swimming in the sun's breath. It was drifting in the ocean of the Milky Way. This transition is an invisible wall, a place where the solar wind finally loses its strength and is pushed back by the pressure of the interstellar medium. Consider the physics of this threshold. For billions of miles, Voyager had been carried by a wind of particles moving at millions of miles per hour. This wind creates a bubble, a sanctuary of sorts that protects every planet in our system from the harshest radiation of the deep cosmos. To leave this bubble is to leave the only sanctuary humanity has ever known. It is a transition from a known environment to a wilderness that has never been touched by human eyes or instruments. The measurements recorded during that crossing were not just numbers on a screen. They were the first biological footprints of Earth, placed upon the shores of the interstellar void. The probe is now a lonely sentinel, recording the properties of a space that is colder and more silent than anything we can simulate on Earth. It measures the magnetism of the galaxy, the flow of ions, and the subtle whispers of plasma waves that have traveled for thousands of years to reach its antenna. Every bit of data transmitted back to Earth is a victory over distance. The signal, traveling at the speed of light, now takes over 20 hours to reach us, a ghostly echo of a machine that is effectively a relic of the 20th century. It is a piece of 1977 technology operating in a region of space that defies 1977 physics. We often think of the solar system as a defined territory, a set of planets orbiting a central star. But the work of Voyager 1 reveals that our home is more like a bubble drifting through a storm. The edge of that bubble is not a line on a map, but a region of intense pressure and turbulence, where the solar wind clashes with the galactic wind in a celestial struggle for dominance. By crossing this border, Voyager 1 has become the first human object to exist outside the influence of our parent star. It has entered the true dark. This movement is a slow drift into the unknown. The probe does not feel the crossing. It does not know that it has left the solar system. It simply continues to follow its trajectory, its instruments humming in the freeze of deep space, sending back a steady stream of data that tells us we are finally, truly alone. The scale of this isolation is almost impossible to grasp. If you were to stand on the hull of Voyager 1, the sun would no longer be a warm disk in the sky. It would be just another bright star, indistinguishable from the thousands of others surrounding it, providing no heat and no light to guide the way. The plasma density measurements confirm that the probe is now interacting with the local interstellar cloud, a region of gas and dust that the sun is currently passing through. This cloud is a thin veil of matter that stretches across light years, and Voyager is the only instrument we have ever sent to touch it directly. It is sampling the raw material of the galaxy, tasting the remnants of ancient supernovae, and the breath of distant nebulae. This is the reality of the interstellar medium, a place where the density of matter is so low that a volume of space the size of Earth might contain only a few atoms. Yet it is this very emptiness that defines the boundary of our existence. The transition from the heliosphere to the interstellar void is a spiritual crossing as much as a scientific one. It represents the moment humanity ceased to be a planetary species and became an interstellar one, even if only through a proxy of aluminum and gold. We have extended our reach beyond the limits of our own star's breadth. We have sent a witness into the dark to tell us what lies beyond the gate. This transition separates our home from the vast neighborhoods of the Milky Way, and yet there is a profound distinction between the journey of the Voyagers and the newer explorers we have sent into the outer dark. To understand this, we can look toward New Horizons, the mission that flew past Pluto and pushed into the Kuiper Belt. While both are messengers of humanity, their purposes are fundamentally different. New Horizons was designed for mapping. Its mission was to catalog a region, to take high-resolution photographs of icy worlds, and to chart the geography of a frozen frontier. It is a cartographer of the periphery, documenting the debris and the dwarf planets that linger in the sun's outer reaches. But the Voyagers are not cartographers. They are exiles. While New Horizons seeks to map the neighborhood, the Voyagers are seeking the exit. There is a critical difference between observing a region and leaving a system entirely. Mapping is an act of definition. It is about finding the boundaries of what we call home. Exiting is an act of surrender. It is the process of moving so far that the very definition of home ceases to apply. The Voyagers did not stop to inventory the Kuiper Belt. They simply passed through it, treating the farthest reaches of our solar system as a doorway rather than a destination. The scale of this departure is measured in a constant, unrelenting velocity. Voyager 1 is moving away from us at approximately 17 kilometers per second. This is a speed that the human mind cannot truly feel. To us, 17 kilometers per second is an impossible blur, a violent rush of distance. But in the context of the interstellar void, it is a slow, meditative crawl. At this pace, the probe is a needle threading through a continent of emptiness, crossing distances that make the entire solar system look like a small, cluttered room. Consider the physics of this drift. Because there is almost nothing in the vacuum to slow it down, the probe maintains this velocity with a haunting consistency. It does not accelerate toward a goal, nor does it decelerate for a landing. It simply persists. This is the reality of a true interstellar trajectory, a straight line drawn across the dark, stretching toward a horizon that never arrives. When New Horizons looks back, it sees the Kuiper Belt as a place to be studied, a collection of objects with names and orbits. When Voyager looks back, it sees a system that is shrinking. The planets are no longer targets for flybys, they are receding points of light. The entire architecture of the solar system, the orbit of Neptune, the vast cloud of the Oort, is becoming a singular, distant memory. This is the difference between a scout and a ghost. A scout goes out to bring information back about a place. A ghost leaves because it no longer belongs to the world it came from. The Voyagers have transitioned from being tools of science to being symbols of distance. They are no longer measuring the planets, they are measuring the void between the stars. As the probes drift further, the concept of a mission begins to dissolve. In the early days, the mission was a series of checkboxes: Jupiter, Saturn, Uranus, Neptune. Then it became a series of boundaries: the termination shock, the heliopause, the interstellar medium. But now the mission is simply the movement itself. The purpose is no longer to find something, but to be somewhere that no other human object has ever been. We are witnessing a shift in the nature of exploration. For centuries, we explored to conquer, to map, or to understand. The Voyagers represent a different kind of exploration, the exploration of absence. They are teaching us what it means to be truly outside. They are the first objects to experience the silence of the galaxy without the protective bubble of the sun's wind. Every second that passes adds another 17 kilometers of distance between the probe and the last place it ever felt the warmth of a star. This is not a journey toward a destination, but a journey away from a center. It is a linear progression into a darkness that does not end. While other probes may find new moons or hidden oceans, the Voyagers have found something more profound: the absolute scale of our isolation. They have moved past the point where mapping is possible, because there are no landmarks in the interstellar void. There are no coastlines, no mountains, no borders. There is only the steady, rhythmic pulse of a machine moving through a vacuum, carrying a golden record and a few remaining sensors into a night that lasts forever. This exit leads us to a quiet, existential realization. In the deep time of the cosmos, the Voyager probes have ceased to be mere tools of telemetry and have become something far more fragile: a postcard sent to a future where the Earth they describe may no longer exist. We are no longer talking about years or decades, but about the slow, grinding scale of galactic rotation. On a timeline where stars are born and die, a piece of aluminum and gold-plated copper is a flicker, yet it is the only flicker we have ever sent into the abyss. This is the creation of a biological archive, a small humming box of memories designed to outlast the very species that dreamed it into existence. Here is where the journey shifts from the scientific to the existential. In 1990, at the request of Carl Sagan, Voyager 1 turned its camera back toward the inner solar system one last time before powering it down forever. The resulting image, captured from 6 billion kilometers away, showed a single microscopic speck of light suspended in a sunbeam. This is the pale blue dot. In that one photograph, the entire history of the human race, every war ever fought, every empire that rose and fell, every person who ever loved or suffered, was contained within a single pixel of light. The pale blue dot was not just a photograph, it was a shift in human perspective. It provided a concrete visual measurement of our cosmic insignificance. And when you look at that speck, you realize that the borders we draw on maps are invisible from the interstellar void. The conflicts that seem all-consuming on the surface of that dot are silent and meaningless in the vacuum. The image stripped away the illusion of centrality, replacing it with a profound, quiet humility. It revealed that we are not the center of the universe, nor even a notable feature of our own galaxy, but a small, fragile community clinging to a lonely rock. The Voyager probes are now carrying that realization further into the dark. They are witnesses to our solitude. While the Golden Record speaks of our music, our languages, and our laughter, The pale blue dot speaks of our scale. Together, they form a complete portrait of humanity, our desperate desire to be known, and the crushing reality of how small we are. The probes are drifting through a region of space where the light of our sun is just another star in the distance, and the Earth is no longer a world, but a memory of a coordinate. We must consider the possibility that the Voyagers are the only things that will ever remain of us. In a few billion years, the sun will expand, consuming the inner planets and erasing every city, every book, and every bone. The Earth will be gone, its atmosphere stripped, its oceans boiled away. But out there in the freezing silence of the interstellar medium, the Voyagers will still be drifting. They will be the last physical evidence that a biological intelligence once existed on a small blue world. They are our only immortality carved into the vacuum. This is the paradox of the mission. We sent them out to find answers about the outer planets, but they ended up providing an answer about us. They showed us that our only true home is each other, because there is nowhere else to go in a void this vast. The distance the Voyagers travel is a measurement of the gap between our ambition and our reality. We have the will to reach the stars, but we are bound to a speck of dust. As they drift, the probes are essentially filing the history of the 21st century into the space-time of the Milky Way. They are markers in the dark, drifting through the local interstellar cloud, passing through regions of plasma and dust that no human eye will ever see. They are ghosts of a technological era, carrying the echoes of a world that is, from their perspective, already a distant ghost. The silence surrounding the probes is not empty. It is a heavy pressing silence that reinforces the scale of the journey. Every kilometer they gain is a layer of insulation between us and them. They are moving away from the warmth, away from the light, and away from the possibility of ever returning. They are the first emissaries of a species that has finally accepted its own smallness. Yet the machine is running out of the very energy that keeps it awake, and yet the heart of the machine is slowing. Deep within the chassis of each probe lies a radioisotope thermoelectric generator, a small furnace of plutonium-238 that converts the heat of radioactive decay into the electricity needed to keep the heaters running and the transmitters screaming across the void. For nearly half a century, this slow burn has been the only thing keeping the freezing dark of interstellar space at bay. But radioactive decay is a clock that cannot be paused. Every year, the fuel diminishes and the power drops. The mission's telemetry tracks this decline with a precision that feels almost clinical. NASA engineers are now forced into a series of heartbreaking choices, turning off scientific instruments one by one to preserve the remaining wattage. First, the plasma wave subsystems, then the magnetic field sensors. Each lost a darkening of a window through which we viewed the unknown. We are watching the probe go blind, then deaf as it prioritizes the basic warmth required to keep its circuits from shattering in the absolute zero of the vacuum. There is a specific deadline etched into the telemetry. By the year 2030, the power levels will drop below the threshold required to operate even a single scientific instrument. This is the moment the transmission ends. The radio signals, which already take nearly a full day to travel from the probe to the deep space network on Earth, will simply stop. The carrier wave will flatten into the background noise of the cosmos. The high-gain antenna, which has served as our only tether to the edge of the solar system, will become a useless piece of gold-plated aluminum. We expected these machines to be tools for discovery, Instead, they are becoming monuments. When the power fails in 2030, the Voyager probes will not vanish, but they will cease to be explorers. They will transition from active observers to silent artifacts. They will become the most distant objects ever built by human hands, drifting in a state of permanent hibernation. No more data on the density of the interstellar medium, no more measurements of the galactic magnetic field, just the cold physical presence of a machine that once knew the warmth of a launch pad in Florida. This fading is a slow, rhythmic exhale. We are witnessing the death of a technological consciousness, a process documented in the daily logs of the Jet Propulsion Laboratory. Each watt lost is a step further into the silence. The probes are not crashing or exploding. They are simply running out of breath. They are drifting into a sleep from which they will never wake, carrying the golden record and the memory of a blue planet into a dark that does not know how to remember. Here is where the scale of the tragedy meets the scale of the triumph. We are losing the signal, but we are gaining a legacy. The silence of 2030 is not an end, but a transformation. The probes will no longer tell us where they are, but they will still be there, moving at 17 kilometers per second through the local interstellar cloud. They will be physical evidence of a dream that refused to stay grounded, a pair of metal seeds cast into a garden of stars. Even in silence, the journey continues forever. The silence that follows 2030 is not a void, but a transition into a different kind of existence. While the instruments go dark and the radio waves cease, the physical object remains. The Voyager probes are now bound by the cold, immutable laws of celestial mechanics, drifting through the interstellar medium as relics of a biological era. They are no longer messengers, but passengers. If we extend our vision across the timeline of the galaxy, the scale of their journey becomes truly haunting. The probes are not drifting aimlessly. They are following a trajectory written in the gravity of the stars. In approximately 40,000 years, Voyager 1 is projected to pass within 3 light years of a star designated as AC Plus 793888. Picture the scene in that distant future. A small gold-plated machine, frozen in the absolute zero of space, gliding through the outer reaches of a foreign solar system. The star AC Plus 793888 will be a distant sun to a world we will never know, and the Voyager probe will be a ghost passing through its periphery. By then, the civilization that built it may be unrecognizable, or perhaps the very memory of the 20th century will have dissolved into the dust of planetary history. Yet the golden record will still be there, etched in gold and copper, carrying the laughter of children and the sound of a rainstorm from a world that existed 100,000 years prior. This is the ultimate expression of human longing. We have cast a bottle into the cosmic ocean, knowing that the shore is light years away, and the current is eternal. The probe becomes a bridge across time, a physical piece of Earth that refuses to decay. It is a singular point of continuity in a universe defined by change. The journey does not end because the power fails. The journey ends only when the machine is consumed by a star or torn apart by a black hole, events that may not happen for millions of years. Until then, the Voyagers are the only parts of us that have truly escaped the cradle. They are the vanguard of our species, drifting in a state of permanent, peaceful hibernation. As we settle into the stillness of the night, we can find comfort in that drifting silence. We are linked to those distant sparks of metal, sharing the same origin, the same curiosity, and the same inevitable drift into the dark. The probes are not alone. They carry the essence of every hand that tightened a bolt and every mind that calculated a trajectory. They are our echoes, traveling forever. Sleep well tonight, and tomorrow we will continue to explore the deepest mysteries of the cosmos. Subscribe to Drift with us again.